Good morning, ladies and gents. All right, so today we're going to be doing coordinate geometry, which is starting on page 23. But make sure that you have, at the very least, pages 1, 2, and 3 out on your desk. All right, so there's a couple things I want to point out. So if you go onto page 2, so on page 2, at the bottom of page 2, there's some extra space. We're going to write some stuff in this extra space. So in that extra space, let's draw this right here. Okay, we're going to be talking about coordinates. Coordinate geometry. All right, so coordinate geometry. So next to the squares, we're just using this extra space right here. All right, so a couple of things that we want to point out. So we're going to be doing two different things here. So first of all, talking about our steps. Okay, so the steps to do this. All right, so the first step you need to do is find the side lengths. And to find side lengths, we're going to be doing a squared plus b squared equals c squared. A squared plus b squared equals c squared. Okay. All right, the second step you're going to do is find the slope. And to find the slope, okay, when it goes up versus when it goes down. Right. If it rises from left to right, it's a positive slope. If it falls from left to right, it's a negative slope. So we're going to do rise over run. Okay, and the third step, you're going to classify. You're going to classify it by either, if you're looking at this, rhombus, rectangle, kite, all those things. So whatever it may be, you're going to classify it by whatever it's supposed to be. Okay, and then, and those are steps right there. So is it going to be, a parallelogram? Is it going to be a rectangle, rhombus, square? Is it going to be a trapezoid, isosceles trapezoid? Is it going to be a kite? Or is it just none of those and just straight up a quadrilateral, just a four-sided shape? All right. So those are the different things that you could possibly classify it by. Oopsies. There we go. That's the button I wanted to push. Okay, so we have that. Now that we have those, now what are the next things that we need to talk about? For slope, let's talk about slope for a second. For slope, okay, so just what we talked about just a second ago. For slope, remember, when it rises from left to right, it is a positive, and when it falls from left to right, it's a negative. Now let's talk about parallel and perpendicular. Okay, so when it is a parallel slope, meaning they never intersect. Meaning that they never intersect. So that right there, and won't if the lines continue forever and ever. Okay, that means you have the same exact slope. So that would be the same slope. Okay, and then what if it says perpendicular? Okay, that means when they, so this is the sign for perpendicular, that means that they intersect at a 90-degree angle. They intersect at a 90-degree angle. Okay, so how do you get that? That means you have flipped the sign and you have flipped the fraction. I have some space right here extra, so I want to give you an example of what that looks like. Okay, so if we did this right here, and let's say that this was 2 and this was 3. Okay, so the slope, so if this was 2 and this was 3, this would be, so I see how it rises from left to right? That's a positive 2 over 3. So I rose 2 and I ran 3. All right, what about this one? Okay, so on this one, see how it falls from left to right? That's a negative. And let's say it rose, this is rising 3, and it ran 2. So if this was 3 and this was 2. All right, what about this one? Okay, this one rises from left to right, so it's a positive, and it rose to, this is 2 right here, and this is 3, just making stuff up for you. And then this one right here. All right, let's say that this part right here was 2 and this was 3. So this is falling from left to right, so it's a negative. And it rose 3, it ran 2. So we're looking at these right here. Okay, so notice that the opposite sides, they're exactly the same. That both of them were positive 2 over 3, and this right here is negative 3 over 2. So at the very least, those are parallel to each other. That's very important. Okay, so at the very least, it's a parallelogram. Now, let's look at the intersections. Okay, so this right here is positive 2 over 3, and it intersected with this side. So we're trying to see, is this right here, is that a 90-degree angle or not? Well, let's compare the two. Are they perpendicular to each other? Yes, they are. Because you flip the sign, that's now a positive, and you flip the fraction from 3 over 2, it turns into 2 over 3. And so what happens is, this right here is 90 degrees. Same thing on this one. These two right here, this and this, those are perpendicular to each other. Same here, same here. So that would make this, at the very least, a rectangle. But when you do the side lengths, you also find out that they are equal to each other, so it's a square. So I was just wanting to give you an example of that. All right, so let's go to page 23. So we are on page 23. So on page 23, okay, you are going to classify this. So we don't really care about the top here because we kind of just talked about that. All right, so you're going to classify it by a parallelogram, a rectangle, a rhombus, a square. Okay, so for that, okay, so what you want to do is have like the shapes drawn, but maybe even more exaggerated than they already are right here, and just know a couple of things. For a parallelogram, we know that these are equal, those are equal, stuff like that, but also know that by the rules that the diagonals bisect each other. So this is equal to this, and then a separate equalness. These two are equal to each other. Okay, also for a rectangle, all 4 of these are equal to each other. For a rhombus, we know that all these sides right here are equal to each other. So, but in addition to that, these are all 90 degrees. And this is equal to this, and separately, this is equal to this. Okay. And even more separate from that, we also know that this equals this. All 4 of those are equal. But we really don't care for coordinates, so we don't really care about that part. So I'm just going to erase that because reasons. Okay. Anyway, and then and we also know that all of these are equal. and these are all 90 degrees. All right, so those are a couple of different rules. We don't really need to know this part, just putting that in there. Okay, so now let's actually do this. All right, the first thing you're going to do is make sure that you plot these. So on number 1, plot them. I am going, just to save you time, and I plotted it for you. So this is, so A, B, C, D. So A is positive 9, negative 4. And you just plot all the points. So I just saved you time, I plot them for you. Okay, now if you just look at this, what do you think this is going to be? So what is our guess? What is the guess for this? If you look at this, you're pretty sure it's, I think it's a rectangle. Now, sometimes it's going to be true, sometimes it's not. So, but that is our guess. All right, so my suggestion is you guess this and just see how good you're guessing. And now let's just double check. Let's just double check that our guess is good. Okay, so we're going to, there are 2 steps. Well, there's 3 steps, but basically there's 2 steps of this. And those steps, on the bottom of page 2, we said find the side lengths and then find the slope, right? Okay, so how do we do that? First of all, we're going to make little rectangles. All right, so this right here, 1, 2, 3. And then right here, 1, 2, 3, 4, 5, 6. Okay, so basically think about it this way. Okay, so this right here, so on the inside, I like to put the side lengths on the inside. All right, so when we're doing this, we're doing 3 squared plus 6 squared. 3 squared plus 6 squared. And we would get 9 plus 36, which is 45. Right? Square both sides, you have the square root of 45. Now, obviously, I showed more work than I needed. Okay, so this right here is the square root of 45. All right, let's do it again. All right, this one right here. Okay, this is 1 by 1, 2. So that's 1 squared plus 2 squared equals x squared. That's 1 plus 4, which equals x squared. That's 5 equals x squared, square root of 5. Okay, and then this one right here, that is 1, 2, 3. That is 1, 2, 3, 4, 5, 6. And that's 6 squared and 3 squared. Oh, wait a minute. Didn't we do a 6 squared and 3 squared, or a 3 squared and 6 squared? Yeah, we did. So that's a square root of 45. Square root of 45. And over here, it's a 1 by 2. Didn't we do a 1 and a 2? Yeah, we did 1 and 2, which was square root of 5. So we put all the side lengths on the inside. Now, please notice that the opposite sides are equal to each other. So these 2 are equal, these 2 are equal. So that narrowed it down to either being a rectangle or a parallelogram, which is awesome. So that's either going to be a rectangle or a parallelogram. So that narrowed it down. Okay, so all we have to do now is double check. We just need to double check that these make a 90-degree angle. So now our second step is to look at the slope. Okay, so for the slope, now I'm going to change my colors. So looking at the slope, we know that when it rises from left to right, it's a positive. And when it falls from left to right, it's a negative. And it is rise over run. All right, with that idea, so I'm changing my colors. Okay, so right here, so inside the triangles, basically, I'm going to write this. Okay, or you can just draw it over here in a separate thing, right? Whatever makes you feel better. Okay, right here. So is this a positive slope or a negative slope? That would be a positive. That's a positive slope, and it rose 3, and it ran 6. Ooh, we need to simplify that. What can you take out of 3 and 6? You can take out of 3. So that's really a positive 1 over 2. So I divide top and bottom by 3. So this is a positive 1 over 2. So it's a positive 1 over 2. Okay, now on this one, right here. So is this a positive slope or a negative slope? That right there is a negative slope. It falls from left to right, so it's negative. And I rose 2 and I ran 1. And that's as simple as you can get it, other than making it into a -2. But while we're working with it, we want to keep it as a fraction. Now, just looking at this, look at that. We flip the sign and we flip the fraction. So that makes this a 90-degree angle. And we know, because it's a parallelogram, at the very least, if one of these is right, they're all right. So so this is a right angle, so this makes this a rectangle. And look at that. Our guess was correct. We had a good guess. So at the very least, you guys could have gone, it's a rectangle. But for this, I need to make sure that you guys need to make sure you do the work for this. All right? You guys need to make sure that you're doing the work for this. So another fallback would be just make sure that you draw this as perfectly as possible. Use graph paper. You have to use graph paper if you're going to do it this way. Once you draw it, you can take the corner of your paper and line it up. And yeah, that makes it's a 90-degree angle. But if you're doing this, if you drew your own graph and you drew your graph paper, like the grid lines, you can't trust you putting like, oh yeah, it's 90 degrees. All right, so our guess was really good. So here's our work. We found the slopes for this. So we're good. Okay, next. So we are now on page 24. All right, so just looking at this sucker. Okay, so after you graphed it, let's look at this. Now, what shape is this? It really looks like a rhombus or a square. And just to make sure, I line up my paper. That's definitely not 90 degrees. So, but I think that these are equal to each other. So if you line this up and you measure this, so that so from R to Q, that's this distance, and S to T, that's that distance. I line this up. So I'm basically just using like a little ruler here. Yeah, those are all the same little distances. So my guess, I'm guessing at this, like it's definitely not a square because this is not 90 degrees. I'm pretty sure that this is a rhombus. Okay, now all we have to do is double check. So let's see if our guessing was good. All right, so just go through the same motions. So first, we want to find all of the slopes. Or in this case, I know for a fact that this is not 90 degrees. So really all I want to do is check the side lengths. So let's just check the side lengths. So make the right triangles. This right here, that is 2. That's 1, 2, 3, 3. Okay, so we just want to check the side lengths. So 2 squared plus 3 squared equals x squared. That's 4 plus 9. That is 9, 10, 11, 12, 13. So square root of 13. All right, so that right there is the square root of 13. All right, this one, 1, 2, 3. 1, 2. Didn't we do a 3 by 2 a minute ago? Yeah, we did. That's the square root of 13. This right here, 1, 2. 1, 2, 3. Yeah, that's another 2 by 3. That's the square root of 13. And this right here is another 2 by 3. That's the square root of 13. Okay, so that narrowed it down. Definitely, that is either going to be a rhombus or a square. So it's a rhombus or a square, and this right here is definitely not 90 degrees. So that sucker is a rhombus. I had a good guessing. Now let me prove to you about the slopes, just in case you're curious. Okay, so this is a positive. It's a positive slope because it rises from left to right, and then I rose 2 and I ran 3. And this one over here, that's a negative slope, awesome, and I rose 2, ran 3. Yeah, so I flipped the sign, but I did not flip the fraction. Okay. So just looking at this, after you draw it, you can go, I'm pretty sure that that's a rhombus. Go the extra step and measure it with your piece of the paper. Okay, and this one is a positive slope, and it rose 2, ran 3. This is a negative slope, and it rose 2, ran 3. You flip the sign, but you did not flip the fraction. This is not a right angle. So that is definitely a rhombus, not a square. All right, number three. So on number 3, the first thing you want to do is graph this. All right, so the first thing we did was graph it. Okay, now this is an important thing. You want to figure out the parallelogram. So we have 3 of these. Now you have to be careful. You need to make sure you're going in order. So let me explain this. All right, if you have this right here, where this is A, B, and A, B, and C. All right, so to make a parallelogram, here are your choices. For this, it could be over here. See how that would make a parallelogram? It could be over here. See how that would make a parallelogram? Very bad positioning, but, and then this right here, it'd be right here. See how that makes a parallelogram? Should be right there. That's where I should be. Okay. Okay. So these are your 3 choices. Now it all depends on your letters, where you're putting stuff. So if I was going A, B, C, D, so A, B, C, this doesn't make sense because I would go across the shape. So this doesn't work. A, B, C, D. Nope. A, B, C, D. See how I would be cutting across the shape when I go back to A? So this one's also bad. So A, B, C, D, you have to be going around in the circle. So this is your answer. All right. So you would have to go like this. Okay, so just be mindful of that. All right, so here we go. So they said J, K, L, M. That's what they want. J, K, L, M. I'll just write it right here. J, K, L, M. So J, K, L, M. So I would have to be going around in a circle like this. So it has to be somewhere over here. Has to be somewhere over here. All right, so we just need to figure out a pattern. So I know for a fact that we're connecting these right here. So J to K to L. Okay, and the other one would be over here. So you just need to find a pattern. So there's 2 different ways. I could look at this pattern and do the same pattern here, or I would do this pattern and do the same pattern here. So let's see. So this pattern right here, that is, so if I do this pattern right here, this is 1, 2, 3 by 1, 2, 3. So I would have to make the same 3. So right here, I would go from K to J. I would have to, that'd be the same thing from L to M. So I would have to do the same pattern. So K and K and J are in the same position as L and M. So how I get from K to J is the same thing of how I get from L to M. So I just have to, so I went down 3 over 3. So 1, 2, 3, 1, 2, 3, and I would land right here. So I went down 3 to the left 3. So I would do that pattern. So you basically just copy paste that pattern and do it right there. Okay, so what is that location? So I'm gonna put little dots, dotted lines right there. Does that look legit? Yes, it does. Okay, so RM is right here. That's what we just found. Now, where's that location? Our answer is positive 1, 2, 3, 4, 5, 6, 7, 8. So positive 8, comma, 1, 2, 3, 4, 5, 6, 7. So positive 8, positive 7, just double checking. 8, 7. Yes. Okay, and that is our answer. And you got to be careful. Are they asking for the x or y coordinate? They just said give me the coordinate, and that is your answer. All right, awesome. Okay, and let's go ahead and do number 25. Let's do page 25. I want you to get used to that. All right, so let's look at this shape. Just looking at it, what do you think that is? Yeah, most of you guys are going, oh, that's a square, and you're correct. So looking at that, that's a square, but we need to double check that that's correct. So we need to measure this. Okay, so we need to find the side lengths. So going like that. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 by 1, 2, 3, 4. So it's a 10 by 4. Over here, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 by 1, 2, 3, 4. Yeah, it's a 10 by 4 again. All right, awesome. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4. So it's a 10 by 4. And over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4. Yes. So all these are 10 by 4s. Fantastic. So we would do 10 squared plus 4 squared on every single one, and they would end up the same because they are the same exact equation. So that would be 116. So 116 equals x squared. So square root of 116 of each side. Notice I'm not simplifying these because they didn't ask me, so we can just leave it as the square root of 116. Make sure we put the square roots on those. Okay, so yeah, so all those are the same. And then just looking at this, okay, so we had a square there. All right, so we had we rose, so that's a positive, and that would be a 10 over 4. So 10 over 4, and if you simplify that, you can take out 2 out top and bottom, that's a positive 5 over 2. So we have positive 5 over 2. Over here, we fell, so minus, and we rose 4, ran 10. Oh, we can simplify that. That's negative 2 over 5. And this one would be the same thing, positive 5 over 2. That would be a negative 2 over 5. Okay, now look at the slopes. We flip the sign, and we flip the fraction, so the intersection of those two slopes would be a right angle. And that proved it. But we basically just looked at that and go, square. And we just double checked our answers. Okay, on this one, just look at that. What do you think that is? I'm pretty sure that is that right there is a parallelogram. But let's double check the side lengths here. So notice I'm just measuring this. Yep, those checked out. And then let's measure this side length. Yeah, those look legit. So I just double checked the side lengths because it could have been off by just one little grid mark. But let's double check. Okay, so measuring this right here, that is a 1 by 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a 1 by 9. So 1 squared plus 9 squared. Okay, and this one is 4 by 2. So we have 4 squared and a 2 squared. Okay, and over here, all right, make sure that you start at the corner and you make sure you go to the dot, because I would have, if I'm not paying attention, I might end up here. So make sure you go all the way to the dot. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 by 1. And same thing here. That is a 4 by 2. All right. So I feel really good that these are the same because they both have the same dimensions. So that's definitely not a square. It's not a rhombus because they're not all the same. So that's definitely a parallelogram. Okay, so we have, this was a parallelogram, and this right here was a square. All right, now, number 3. Okay, so we are trying to answer these questions. Okay, in order to answer these questions, if you can think of one counterexample, it is false. All right, let's do it. Okay, so which statement is always true about a parallelogram? So the best way to do this is to draw an exaggerated picture of a parallelogram. There. So it's my exaggerated picture, so I have these little lines on there so that I know that the side lengths are the same. Okay, so looking at this exaggerated picture, okay, and they're talking about diagonals, so let's go ahead and draw the diagonals. So connect the dots here. Oh, crap. There. All right, so looking at that, okay, so the diagonals bisect the angles. So do you think that this angle right here is equal to this angle right here? No, so that's false. But you need to make sure that you check all of your answers, okay? Because if you get 3 wrong and 1 right, then you might have just misread it because they're like, which one's false? Which one's the only one that's true? That kind of thing. Okay, diagonals perpendicular. So do these intersect at a 90-degree angle? No. Okay. Adjacent sides are congruent. So adjacent sides. If you didn't understand what that means, just skip it and go to the next one. Adjacent sides. So sides that are next to each other. Are they congruent? So is this side equal to this side? No. And finally, diagonals bisect each other. Do these cut each other in half? Yes, they do. And if you weren't sure about this, then you would need to flip back to your page number 1 about parallelograms. And you could just read your rules. So which one of those were true? Diagonals bisect each other. So I was on page 1. So that was another thing you could have done. So there's that. So the answer was D. Okay, number 4. Quadrilaterals has diagonals that are congruent. Okay, the only time that diagonals are congruent, the only time that happened were 2 different things. So and this is very important for you to know. So diagonals being congruent only happen twice. For a rectangle and for an isosceles trapezoid. It's the only time that diagonals are equal to each other. It's the only time. Okay? So square is gone and the rhombus is gone. Okay, so with that, okay, but they're not perpendicular. Okay, so these, and actually a square as well. So a square works as well. Boom. Because a square is a rectangle. So square was a possibility, but I knew it was going to be crossed out because they said not perpendicular. So square is totally gone. Boom. So it can't be a square. Okay, and then the quadrilateral contains no right angles. So a rectangle has a right angle here, 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 and here. So it's definitely not a rectangle as well. So the only thing left was isosceles trapezoid. Okay, number 5. Which statement is not always true about parallelogram? Okay, so we have the rules for parallelogram right here. So opposite sides are parallel. That is always true. So I'm just going to put a check mark there. And so and I told you to check every answer. Half of you guys would have stopped right there, but they said which one is not always true. Okay, opposite sides are equal. That is a rule, so that's always true. Oh, there's 2 check marks. Look at that. So that means we're looking for what's not good. Opposite angles are congruent. Let's see. Oh, there's right there. We're going actually in order. So that's always true. And diagonals are equal. The only thing that they said about diagonals being equal, or diagonals at all, is diagonals bisect each other and diagonals create 2 congruent triangles. So that one is not always true. And here's an actual example right there. This and this are equal. This and this are equal. But does this completely equal that? No, it doesn't. So that is our answer because that one was the only one that was wrong. And finally, number 6. So if quadrilateral ABC is a parallelogram, okay, the only way that this will make sense is if you make a parallelogram and go A, B, C, D. It doesn't matter where you start, just as long as you go in a circle saying A, B, C, D. If you cut across, it will be wrong. All right, so let's see. So will AC all right, does AC equal BD? Does this equal this? Now, it's kind of hard to tell, so I'm going to go draw my my exaggerated parallelogram, and then you should be able to tell a little better. Okay, so now if we do A, B, C, D, let me connect the dots. All right, so now does AC, oops, see how I cut across? That's bad. So A, B, C, D. Okay, so does AC equal BD? Does that look like this and this are equal? No. All right, does AC, or sorry, are they perpendicular? No, that's definitely not 90 degrees. Does this equal this? And if you're not sure, measure it. So that is this distance, or let's do a corner paper. You can see that better. All right. So we have this distance, and does that equal that? Nope. That right there ended up here. I wanted all the way over here. So no, that didn't work. Okay, does AC bisect this angle A? So did AC cut A? So does this and this equal? No, they do not. And finally, does AC bisect? Does this part equal this part? And does this equal this? Yes, it does. So the answer was D. D was the answer. Okay, so now you guys have a main idea of how to do this. So make sure you put those answers into teams. And it is your job to finish 26, 27, 28. Make sure you guys get those squared away. All right, have a great and wonderful day. I lost my mouse. All right, have a great and wonderful day.